Greetings, and a quick disclaimer because of safety reasons. The substances shown in this video are hazardous, and if you're going to do anything with these substances because of this video, then talk to a professional that knows these substances well. Now, onto the video. If you click the video, you already know what this video is about. The question arose because we were discussing the properties of the water molecule in class, and in case you don't know, I'll explain briefly. We should all know by now the chemical formula of water is H2O. This means a water molecule is made from two hydrogen atoms joined chemically to an oxygen atom. In class, the professor told us that the hydrogen atoms are positively charged, while the oxygen atoms is negatively charged. This makes the water molecule's atoms attract other atoms of opposite charges of many other substances, hence breaking them apart. This makes water a solvent. And if you don't know what a solvent is a substance able to dissolve other substances. Now, to the main question. What other solvent could replace water? What I mean by that is that I'm looking for a substance that has similar properties of water and that doesn't necessarily have the same uses of their atomical structure in living organisms. And I previously thought water was the only solvent, but that's not true. There are many other solvents, such as acetone, which is what nail polish remover is made from, and diethyl ether, which is the common solvent substance in laboratories. After that, I realized I first needed to answer another question. What makes water so unique that they say is essential for life on Earth? Well, I realized that water meets three criteria that make it unique. It has a simple structure, it's made from common elements on Earth, and it is able to dissolve and mix many substances. On the Wikipedia page about solvents, there is a chart that contains common solvents which are used to select suitable candidates for water replacements. Out of the 26 solvents listed on the Wikipedia page's chart, 2 were simple in atomic structure and in the same solvent category as water. They were methanol and ammonia. Both must meet the 3 criteria I stated before and have similar properties of water. First, let's evaluate methanol. Methanol's chemical formula is CH3OH, which means it has 3 hydrogen atoms joined chemically to a carbon atom, which is chemically joined to an oxygen atom with a chemically joined hydrogen atom. Methanol is a simple solvent and the same type of solvent as water. It is a common substance as gas clouds in space can be made from methanol, but it's highly flammable, which isn't a property of water. So, with that, methanol is out of the question because of its flammability. And that leaves us with ammonia. Ammonia's chemical formula is NH3, which means it has 3 hydrogen atoms joined chemically to a nitrogen atom. Ammonia is simpler than methanol, and that's a bonus. Ammonia is also a common substance as there are amounts of it in planets of the solar system such as Mars and Saturn. And as the first paragraph in the subsection of solvents in the section of applications of ammonia in the article about ammonia on Wikipedia states, comparison of the physical properties of ammonia with those of water shows that ammonia has the lower melting point, boiling point, density, viscosity, dielectric constant, and electric conductivity. Now, I'll explain that quotation if you don't understand what it means. Dielectric constant in simple terms is the amount of energy in the space of something. I think. Electrical conductivity is how much a substance can transmit an electric charge. Viscosity is basically how well a liquid substance flows. And density is how much stuff something has in a given volume. To confirm if ammonia could theoretically replace water, it must not dissolve lipids. Lipids are things such as waxes, oils, and fats. Lipids are essential to life because lipids make up the cell membrane, which is a barrier that separates the inside of the cell with its outer environment. I was going to drop a chunk of wax or lipids in pure liquid ammonia to see if it dissolves, but ammonia is hazardous, stinky, and pure ammonia is difficult to acquire if you're not a chemist, which I'm not. Fortunately, I stumbled across an article on the website of the University of Calgary by Dr. Ian Hunt that states, lipids are all insoluble in polar solvents like water, but highly soluble in the non-polar or weakly polar organic solvents. To explain, I first need to tell you that solvents are classified into 2 main groups. nonpolar, and polar. Ammonia is a polar solvent just like water. And to explain a bit further, polar solvents are divided in two subgroups, called polar aprotic solvents and polar protic solvents. Ammonia and water are polar protic solvents, to be more specific. The statement said that lipids are insoluble in polar solvents, and fortunately, ammonia is a polar solvent like I stated earlier. This means that ammonia can't dissolve lipids. And with that, we answered the main question, that ammonia could theoretically replace water since it can't dissolve lipids. It's made from common elements and it's a solvent. Although ammonia would be a terrible substitute of water because water is stronger at dissolving substances than ammonia. Now, you may be wondering why life didn't use ammonia as its building blocks instead of water. Well, the hypothesis I think is most probable is that water was just common. As you may know, water came to Earth from water-bearing asteroids a few billion years back. And I think that life just evolved to use the substance to its fullest because of its strong solvent properties and abundance. I don't think there was just enough ammonia for life to use in high concentrations. That concludes this video. I hope you enjoyed it and consider subscribing if you want to see more content like this. Now, a disclaimer again. Don't use or experiment with ammonia or methanol without first consulting a professional that knows these substances well. This video is made for entertainment and educative purposes. Don't try to replace water with ammonia because it can lead to the following symptoms. Inhaling it in high concentrations can be fatal. Exposure to ammonia can cause headaches, edema, impaired memory, seizures, and can result in a coma as it is a neurotoxin in nature. Here are the websites and articles I use for researching the information on the subject. en.wikipedia.org wiki solvent, en.wikipedia.org wiki water, en.wikipedia.org wiki ammonia, en.wikipedia.org wiki methanol, en.wikipedia.org wiki relative permittivity, en.wikipedia.org wiki electrical resistivity and conductivity, www.chem.ucalgary.ca courses 350 carry 5th ch26 ch26-0.html. Have a good day and goodbye.